Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on end behavior. So, thus far, we've worked a little bit with polynomials of higher degrees of 3 and 4 and 5, but we want to get a good idea of what these functions look like. And part of that is going to be end behavior. So, we're going to see as x approaches negative infinity or positive infinity, what does f of x approach? And overall, from this, we'll just get a better idea of what these graphs of these polynomials look like. Okay, so let's start off. We have this equation in number 1. F of x equals negative x minus 5. I'm just going to graph this to the left real quick. If we were to graph this, it looks something. We have a negative y-intercept. You know what? I should probably do this in black first. We have a negative y-intercept and a negative slope. So it's going to look something like that. Okay? Great. So no, it's important we just have an idea at first. Okay, so we're first asked for the degree. So the degree basically means when we're in standard form, what's the highest exponent on this x? So for example, this is x to the first. So our highest degree in this polynomial, or our degree of this polynomial, is just going to be 1. So it's this exponent, the highest exponent. And the leading coefficient means on that same term, what are we multiplying that x to whatever power by? So in this case, we have a negative sign out front. So that means we're multiplying by negative 1. And so we notice it's a negative number. Okay, so now, by looking at this graph on the left, does the left arrow, is it going up? Is it rising? Or is it going down? It's falling. Well, it's going up. It's rising. So we're going to say it rises. And the right arrow, is it going up and rising or going down and falling? Well, it's going down and falling. So we're going to say fall. We're going to do some more examples, and then we're going to contextualize this. So essentially what we want to see from these two pieces, direction of left arrow and right arrow, is if we continue this function, this line, what's going to happen to it as we go infinitely on in this direction? Well, it's going to keep on going up, 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 all the way until positive infinity. And this side is going to keep on going down, 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 all the way until negative infinity. Okay, let's look at example 2. I'm going to graph it here. Okay, so we have negative x squared minus 4x plus 5. So we're going to have a function that looks roughly like this, okay? And I'm just graphing the functions at first so that we can get the idea. But once we understand some trends and patterns, I'll point out in a second. Sorry about that. We'll be able to see this equation and see the end behavior, and then that will help us graph. So we'll go in the opposite direction. But I'll do that in a second. Okay, so first, our degree. Well, our degree is our highest exponent. In this case, it's 2. So degree is 2. And it's odd. Or, sorry, it's even. My bad, I'm tripping. Lord. Okay. Even. And this one, by the way, I'm off my game. This one is 1, and it's odd. Okay, great. So we have 2 even, and then what's our leading coefficient? So what are we multiplying this x squared term by? Well, we're multiplying it by negative 1 again. And we see does our left arrow rise or fall? Well, it's falling. It's going down towards negative infinity. So it's going to fall. And same with our right arrow. It's going to keep on going down in this direction. Okay, perfect. Now let's do number 3. Okay. So now we have 2x cubed minus 4x squared plus 3. So I know we have a positive y-intercept, and I know it's going to look something, if you were to graph this on Desmos or on your calculator or something, it's going to look something like that. So when we graph this, first, what's our degree? Well, our degree is going to be 3. And is that odd or even? Well, that's odd. And what's our leading coefficient? So what are we multiplying x to the third by? 2. And that's going to be positive 2. And we see that our left arrow is falling. So it's going to keep on going down in this negative direction. While our right arrow is going to keep on rising up to positive infinity. Okay, we're going to do one more, but look at some of this information, whether it's odd, whether our degree is odd or even, and whether our leading coefficient is negative or positive, and see if you start to notice any patterns. Okay, let's do 4. Okay, so in this case, we have x to the 4th minus 3x cubed plus 2. This graph is going to look something, I believe, should look something like this. I don't know, something along those lines. Maybe shifted left or right. But it's going to look something like that. So our degree is 4, right? We're raising x to the 4th. That's going to be even. Now our leading coefficient, well, nothing is written down, so that's just going to be positive 1. And we see that both arrows are pointing up. They're both rising to positive infinity. Okay, so let's just take a second to analyze this. When we have an odd, let's look at 1 and 3. When we have an odd degree, how do our directions of our left arrows and right arrows change? Well, when both are odd, we notice that the direction of our left arrow and right arrow are different, okay? Because here it's rise and fall, and here it's fall and rise. Now, what's the difference between these two, between 1 and 3? Well, 1 has a negative leading coefficient, and 3 has a positive leading coefficient. So when we have a positive leading coefficient, as our left arrow is going to fall, while our right arrow is going to rise. When we have a negative leading coefficient, our left arrow is going to rise, and our right arrow is going to fall. So let's put this down. You know what? I'm just going to create a graphic for you guys. Maybe you guys can copy this down. Maybe this will be helpful. I don't know. Okay. So we have odd versus even. This is all degree. And this is leading coefficient. So I'm just going to say I'm going to say LC. And this is going to be positive, and this is going to be negative. So we just talked about odd. When we have an odd function. Sorry about that. Okay, when we have an odd function, we know they're going in different directions. When we have a positive leading coefficient, our left arrow falls. So I'm just going to write something like this, while our right arrow rises, something like that. Okay? And conversely, when we have a negative leading coefficient, our left arrow rises, while our right arrow falls. Okay? And based on the degree in different parts of the function, this middle part will change. But we're just looking at generally as we go towards the extremes, as we go towards positive infinity in the x direction or negative infinity in the x direction. How does our y value change? What does our y value approach? Okay, now let's look at evens. Well, even in 2 and 4, our degrees are even. We see that here it falls and falls, and here it rises and rises. So the directions of our left and right arrows are going to be the same. That's when we have an even function. Now, when our leading coefficient is negative, our left and right arrows are going to fall. So let's graph this. Okay, so we just said when our leading coefficients, for an even function, when our leading coefficient is negative, we fall as we approach both negative infinity and positive infinity. Now, conversely, when we have a positive leading coefficient for an even, for a function with a degree that's even, we rise and rise. So we have something like this. Okay. I don't know how helpful this is for you. This makes sense to me, but it may be different for you. If you have any questions about sort of what I'm trying to represent within this graph, feel free to ask. I'm happy to help. But let's use what we just created, this information, to help us answer number 5. So we have x to the 5th times, or x to the 5th plus 3x to the 4th minus 6x cubed minus 8x squared. Well, first, what's our degree? Degree is going to be 5 because our highest exponent is 5. And is that odd or even? That's going to be odd. And now, our leading coefficient, what are we multiplying x to the 5th by? We're just multiplying by positive 1. So, what I want to do now is using that information, do we have an odd function or even function? We have an odd function, so we know we're going to be in this column. And is our leading coefficient positive or negative? Well, it's positive. So I know it's going to be something with this end behavior, where our left arrow is going to fall, and our right arrow is going to rise. Okay? And we'll put this into practice in a second too. So we're asked, what determines if the end behavior of the graph will be same or different? Well, we said here in odd functions, our end behavior for left and right arrows are different. Well, even, they're the same. So we're talking about the degree, whether the degree is even. Whether the degree is even or odd. Now, what must exist for the right end behavior to go down, to fall to the right? So let's look at the cases where our right arrow falls. Well, we have it in this case, right? These two scenarios. So that is as when we have an odd degree with a negative leading coefficient is this scenario. So let's put that in here. Odd degree with negative, I'm just going to write, or you know what I'm going to write, negative LC, or we have, in this case, an even function with a negative leading coefficient. Negative LC. So overall, what must exist? We must have both of these have this. Oh geez, my bad. I'm sorry. This negative leading coefficient. So that's going to be our answer. We must have a negative leading coefficient. Okay. Let's put this into practice here. Okay, so we're trying to describe end behavior. Oh, real quick, what I'm going to do is I'm going to show you some notation. So basically what we're saying when we're saying does the left arrow rise or fall, we're saying as x goes really far in this direction, it goes over here, all the way over here, what happens to our y? Our y goes down and down and down, all the way until negative infinity. It keeps on going down. So we say, in this case, for this specific scenario, we'd say as x goes to negative infinity, since we're going in this direction towards negative infinity, and we write infinity like that, f of x, or y, goes where? Keeps on going down all the way until negative infinity itself. Okay? That's just sort of our notation. We'll practice this right now. Okay, so an even function with a positive leading coefficient. Let's look at what we created. We have an even function with a positive leading coefficient, so it's going to be this scenario. We see that as x approaches negative infinity, what happens to our arrow? Is it rising or falling? It's rising. So we say, I'm going to zoom in here. As x approaches negative infinity, f of x approaches positive infinity. Let's look here for the right arrow. As x approaches negative infinity, or positive infinity, and goes in this direction, what happens to our y? Our y is still rising, so our y approaches positive infinity. So as x approaches negative infinity, f of x, positive infinity, my bad, I'm true, plus infinity. Okay. So now we have an even function with a negative leading coefficient. So that's going to be this case down here. As x approaches negative infinity and goes in this direction, what happens to our y? Our y goes down towards negative infinity. So we're going to say, it's a lot of writing, as x approaches negative infinity, f of x, or y, approaches negative infinity too, because it's going down here. Now, as x approaches positive infinity, as x approaches positive infinity, what happens to our right arrow? It goes down, it falls, so it still approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. Okay. And if you have any questions on any of this notation stuff, just ask your teacher, go to the tutoring center. Definitely just ask a lot of questions, because notation starts to become pretty important in math right about now. Okay, now we have an odd function with a positive leading coefficient. So which case is that going to be here? Well, it's going to be this upper left-hand side, this graph. So as x approaches negative infinity, as it goes in this direction, we have an arrow that's pointing down, so it's falling. It's falling towards negative infinity. So as x approaches negative infinity, f of x approaches negative infinity too. Now, our right side, as x approaches positive infinity and goes in this direction, what happens to our y? Our y keeps on going up, approaches positive infinity too. So we have, as x approaches positive infinity, f of x approaches positive infinity. Sorry. Okay, so odd function with a negative leading coefficient would be this graph right here. As x approaches negative infinity, our left arrow rises, so it's going towards positive infinity. So as x approaches negative infinity, f of x approaches positive infinity. And on the other side, as x approaches positive infinity, y approaches negative infinity. It goes down here. So approaches positive infinity, f of x approaches negative infinity. Yeah, let me just, okay. Perfect, great. Now let's do some practice. So with this information, with this knowledge of end behavior, using with our degrees even or odd and our leading coefficient is negative or positive, we're going to try to get an idea of this graph without graphing. Okay, so in this case, first, what is we're asked to find the degree, so let's do 1. The degree, in this case, is just going to be 3 because we're raising x to the third, which is going to be an odd degree. Now, our leading coefficient is what we're multiplying x to the third by, and that's going to be -6. So this is negative. Okay, and so when we have an odd degree with a negative leading coefficient, let's scroll up to here. Odd degree, negative leading coefficient, it's going to be this graph. So as x approaches negative infinity, goes in this direction, y approaches positive infinity, and as x approaches positive infinity in the x direction, y approaches negative infinity. So I'm going to keep on writing it here because, or you know what, I wonder if I can, I'm going to try something here. No, I don't think that's going to work. Okay. Let's just not do that. Okay. You know what, I'll just write the answer to this off to the side here, to number 1. So, as x approaches negative infinity, f of x approaches, we have an odd degree that's negative, so it's going to approach positive infinity. As x approaches positive infinity, f of x approaches negative infinity. Okay, great. Now, we're also asked to find the domain and range. Now, for any polynomial, our domain is going to be all real numbers. Any polynomial. It's always going to be continuous. So we write that like that. And domain is in the x direction. I think we had covered domain in a previous lecture, so go back to that if you're not sure exactly what that means. And range is in our y direction. And so basically, what we want to see is if they're going in opposite directions, if our f of x, which is our y, is going towards positive infinity and f of x is going towards negative infinity, they're spanning all real numbers because it's going all the way up to positive infinity. It's going all the way down towards negative infinity. So range is also going to be all real numbers. Okay? Now let's do a different problem. Let's do something. What's a good one? Let's do 4. Okay, so our degree, and we'll contrast the two. Our degree is going to be, well, what's the highest exponent we have? We have x to the 4th, so our degree is 4, which is an even number. Now, leading coefficient, we're multiplying x to the 4th by pi. And remember, pi is just a constant. It's not another variable. And so is pi even or odd? Well, sorry, not whether it's even or odd. Positive or negative? Well, it's positive. So we're going to say positive. So we have an even degree with a positive leading coefficient. Let's look here. Even degree, positive leading coefficient, it's going to look something like this. So as we approach negative infinity, our y approaches positive infinity. As x approaches positive infinity, our y approaches positive infinity. So let's write this down. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x also approaches positive infinity. So we see that we have the same ending, right? Both ends up. So in this case, it's not like number 1, in the sense that sorry, my bad. I'm going a little too fast. Let's talk about our domain. This is a polynomial function. So our domain is just going to be all real numbers. And polynomial just means if we have x to the 4th plus x to the 3rd or plus x squared or whatever, you can raise whatever number, whatever value of x, negative 1 million, 0, 1, 3, whatever, to whatever power. So that's why polynomials always have a domain of all real numbers. And our range, well, as I was saying before, our end behavior goes in the same direction. So it's not like over here in example 1, where it goes from positive infinity to negative infinity. So our range is all real numbers. We're going to have to find, where does this function turn around, okay? So the way we do that is just by thinking logically. If we have a negative number raised to the 4th power, we're eventually going to be getting a positive number. If we have a positive number raised to the 4th power, we're going to get a positive number. If we have 0 raised to the 4th power, we're going to get 0. So when we have a positive number times pi plus root 6, we're going to get a number greater than root 6, right? Same for when we have a negative number because, as I said before, negative number to the 4th power is still positive. Now, when we have 0 for x, our 0 to the 4th is 0 times pi is still 0. So we're going to have root 6. And we can't go any lower than root 6. So root 6 is going to be our minimum. It's going to look something like this. I don't know. Sorry, I'm not the best at graphing. Something like that, where our range, so our y value, is going to go from root 6, or sorry, my bad. If I do this interval notation, we have to have a bracket because it includes root 6. And it goes to positive infinity, right? Because both of these are going to positive infinity. I put a parentheses because we can never reach positive infinity. So parentheses means it's not including that. Okay? Hopefully that makes sense, sort of what we did here and how we tried to think about it logically. Imagine the graph, plug in different values of x. If you're ever confused graphing, what I'd always recommend you to do is just start plugging in values for x and seeing what you get. And you'll start to see a trend and just connect those dots, okay? And then you can get an idea of your graph. Okay, so hopefully that was helpful. Hopefully you can do 2, 5, 3, and 6 by yourselves using this information. If you have any questions on any subject within this lecture, any topic I went over, go to your teacher, go to me, go to the tutoring center, go to your peers, and definitely use online as a resource. Okay, thank you. Have a good day. See you.